Now that we're moving over to number 4, and 4, 5, and 6, I wanted to remind you about remembering to use your division skills. Because what we're doing is we're trying to find the simplest form of a fraction. Okay? And so we have a fraction, say 3/6, and it's taking up a certain amount of space of the whole thing. And it's using 3 pieces to completely fill that hole. So for instance, I'll just do a quick drawing of it. Okay, here's the whole candy bar, let's say, and it's divided up into 6 pieces, and it is covering 3 of those. 1, 2, 3. Now it's taking up that entire this amount of space of the whole, but it's using 3 pieces to do that. Is there a simpler way of taking up the same amount of space? And you're already seeing, I imagine you're probably seeing this, that it's really half of the entire thing, right? Because if I went like this and this, can you see how it could just be 1 out of 2 pieces? That is the simplest fraction. 1/2 is the simplest. But without drawing this, how would you figure this out? Well, you can use your division skills and say, all right, I've got 3, I'm going to rewrite this because that's hard to see, 3/6. Can I divide 6 and 3 by a number, the same number, besides 1? And yes, I can divide 3 by 3 and 6 by 3. And when I do that, if I say 3 divided by 3, that equals 1. And 6 divided by 3 is 2. I know that because 2 times 3 is 6, and 1 times 3 is 3. And that brings me to 1/2. That brings me to the simplest form, 1/2. And there you go. Okay? So I'm hoping that as the more we do this, the more it'll start making sense. I know this is a strange concept, but just keep with it. If you're still not completely getting it, you're not alone, okay? Stay with me. We're going to keep at it, okay, as much as we can. So now we have 4/6. How do we get that down to the simplest form? So if I look at it visually, if I divide this up into 6 again, this time there's 4. So it's 1, 2, 3, 4. Not quite as easy to see, right? Because it's more than half. So I can't just say it's 1/2. That's not going to work. So, but it's still taking 4 pieces to cover this amount of space. Is there something else that we can do that would provide less pieces, so they're bigger pieces, and still fill up the same amount of space? Well, let's give it a shot. Let's do 4/6. And is there a number that we can divide by both of these, 4 and 6, that's not 1, besides 1, that will give us something else? I always like to try to find the biggest number possible first. So I look at the number 4 and say, okay, I know I can divide 4 by 4, because that would give me 1. But can I divide 6 by 4? That's not going to work. Nothing multiplied by 4 equals 6. 4 times 1 is 4. 4 times 2 is 8. Not going to work. So now let's go down one more number. How about 3? Can I take 4 divided by 3? No, because nothing times 3 equals 4. 3 times 1 is 3. 3 times 2 is 6. That's not going to work. How about 2? The answer is yes. So let's put 2 here. 4 divided by 2 is 2. 6 divided by 2 is 3. And I know that because 3 times 2 is 6. 2 times 2 is 4. So we have another fraction that's equal to 4/6, equivalent, but now it's only using 2 pieces. So it's now divided up into thirds. Now check this out. I'm going to divide this up into thirds. Okay, there's 1/3, there's 2/3, and there's 3/3. And look at that, 2/3. We have now found the simplest form of that fraction is 2/3. Stay with me. Let's do another one together, okay? All right. Number 6. Number 6, we're looking at 3/8. Okay? I'm going to draw that down here. So I've got my whole fraction strip, and let's divide that into eighths. So I divide that in half, half and half. Now we have fourths, and now I'll divide this in half. And now we have eighths, 8 pieces. And it says there's 3/8. So this piece, and this piece. All right, so we need to figure out, is there a simpler way of showing this fraction? Can we show this same amount of space with less pieces? Let's try it out. We have 3/8, right? What can we divide both of these by besides 1? Can we simplify it down? Well, we'll try it out. Can we divide by 3? Yeah, we can divide 3 divided by 3. That equals 1. 1 times 3 is 3. But can we divide 8 by 3? I don't think so. Because nothing times 3 equals 8. 1 times 3 is 3. That's not going to work. 2 times 3 is 6. That's not going to work. 3 times 3 is 9. Not going to work. So we can't, 3 doesn't work. What about 2? Can we divide by 2? No, because 3 divided by 2, it doesn't work. 1 times 2 is 2. That's not right. 2 times 2 is 4. That's not going to work. So the only thing you have left is 1. And if you remember, that's the definition of the simplest fraction, when the only number that you can divide by is 1. That doesn't change anything, right? 3 divided by 1 is 3. 8 divided by 1 is 8. It's still the same. So 3/8 is already the simplest form of that fraction. There's no way of simplifying it down. Okay. Oops. Delete. Delete. Okay. So now let's take a look at number 7. Rob colored 1/4 of a rectangle. What is another way to name 1/4? Well, one way is could you split these up to be smaller pieces? So can we do this? Like that. Instead of fourths, you now have 1, 2, 3, 4, 5, 6, 7, 8. So now you have eighths. But instead of having 1/4, now you have 2/8. That was one way to do it. You can get really crazy with it and do this. Oh my gosh, I'm going to blow your mind. Look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I went to 16ths, ladies and gentlemen. Oh, yes, I did. And now it has 1, 2, 3, 4. 4/16 is also a way of doing it, but I'm assuming you probably did the 2/8, right? Okay. Now let's look at number 8. Whoops. Oh my gosh. Number 8 says 3/8. So 3/8 of the cast in a musical have to sing? What fraction of the cast does not have to sing? Okay, so if 3/8 have to sing, one way you can draw that out, right? Like that. Divide that into fourths. Uh-oh, I'm getting sloppy. Eighths. 1, 2, 3. Well, what do you have left over? 1, 2, 3, 4, 5. 5/8. I didn't even have to draw this because you know that by looking at 3/8 is that the denominator tells you how many total pieces there are. And if 3 have already been taken up, how many do you have left? 5. Boom. Okay. Numero 9. I don't know why I just said that. When using fraction strips, how do you know that the two fractions are equivalent? Well, if you're using fraction strips like up here, how do you know that they're equivalent? It's when they take up the same amount of space, right? This fraction and this fraction, they're taking the same amount of space. So, how do you know when you're using fraction strips? You could just say that both fractions take up the same amount of space. Just like that. Okay, let's do our last one, guys. Delete. Samuel has 3/6 of his assignment. Judy has read 3/6 of his assignment. Judy has read 4/8 of her assignment. Their assignments were the same size. Which sentence is true? So we have 3/6 versus 4/8. Oh boy. Which is true? Did Samuel read more than Judy? Did Judy read more than Samuel? Did they read the same amount? Or they will both finish the assignment at the same time? Well, we have no idea how long it's going to take for them to do the rest of their assignment, so I think D is definitely out of the question. But A, B, and C, you have to figure this out, right? Okay, so we have, look at that, wow. So we have 3/6 versus 4/8. All right, let's take a look here. 3/6 versus 4/8. Okay, well, if I take one book and I take the second book and I divide the first book up into 6, so I go boom into half, and those are 3, so we have 6 there, and she read 3/6. There's 1/6, there's another 6, and there's another 6. And then the second book I have to divide up into 8ths, so I do that in half, do that in half, do that in half, that's 4ths. Now we have, divide those in half, those are 8ths, and she did how many of them? 4 of them? 1, 2, 3, 4. Oh my goodness. I think we have equivalent fractions here. 3/6 is equal to 4/8. They are equivalent. So the correct answer would be is that they read the same amount. Thanks, guys.